Okay, as I was saying at the end of that last video, we're going to look at a transformation here, but we're not going to actually do it ourselves. So I just want to show you what the picture from your notes, where that comes from. So it tells us that Shay and Carrie are studying transformations. Let's see if I can get to this. They're studying how transformations can be used to discover how the lengths of the sides of a triangle are related. So we know how the angles are related, that they have to add to be 180 degrees, but what about the sides? So in the step, it says that Shay is going to draw triangle ABC. So here is Shay drawing triangle ABC and carefully measures the measure of angle ABC to be 119 degrees and the measure of angle ACB to be 24 degrees. So the next thing that occurs is a rotation around angle B, and it doesn't really matter what that number of degrees was. And then a third triangle is rotated around angle C. So this is the diagram that is created that is on your notes. And so we're going to use this diagram to answer questions number 4 on your notes. So I just wanted you to see where that picture came from. It was a rotation of a repeated triangle around B and around C. So it says on parts A through E that these are our word choices. We're going to choose from the word greater, the symbol greater than, the word collinear, less, AB, and AC. And those are links since it doesn't have the segment bar above there. So in part A it says since angle A prime, A double prime, B, and angle A double prime, B, C, right here. So this angle and this angle each measure 180 degrees. We know that means that these 4 points are all on the same line. And so the word for that is collinear. So since these 3 points make up a 180 degree angle and these 3 points make up a 180 degree angle, that means all 4 of those points are collinear. Part B says since rotations preserve distance, remember they're rigid motion so the side lengths don't change lengths, we know that A prime B is equal to, well, where did that come from before we rotated it? Well, that was side AB. So that was that triangle rotated, so we know A prime B is the same length as AB. Likewise, A double prime C, which is from here to here, came from, this is this triangle we're looking at, and remember that was rotated, that came from the original AC. The order of the points, A prime, A double prime, B, C, that's the order of them, so that we know if we add A prime A's distance to A prime A double prime's distance to A double prime B to BC, that is going to be what in comparison to only from A double prime C? Well, from here to here to here is that whole distance across. A double prime C is not the whole way across, so we know that the whole way across would have to be greater than this to this, which is not all the way across there. But we know that A prime A double prime plus A double prime B made up AB. This distance, remember, is this distance. And we know A double prime C came from AC. It was just that rotated. So this rotated made that A double prime C. So we can substitute into part C to get this statement right here. So really this is this statement right here. So A double prime A prime A double prime plus A double prime B, we're replacing this with what it's equal to, which is AB. So that's where that AB came from, replacing this with what it's equal to. And here's that BC, and then we're going to put our greater than symbol, and instead of A double prime C, we're putting what it's equal to, which is AC. So that's where this AB plus BC is greater than AC. that allows us to come up with this relationship about the lengths of the sides of a triangle. We know the angles add to 180, but that doesn't mean the sides add to 180 degrees. That doesn't make sense. So what we do know is that the sum of the lengths of any two sides of a triangle has to be what in comparison to the third side? And that is greater. Has to be greater than the length of the third side of a triangle. Okay, so this is a really important conjecture because this gives us a relationship about the sides of the triangle, whereas we already know about the angles having to add to be 180 degrees. So let's look at numbers 5 on your notes here. It says determine if the three numbers can be measures of the sides of a triangle. We're going to use this conjecture that the sum of any two sides of a triangle has to be greater than the third side to tell if this can be a triangle or not. So really all we have to do is test the two smallest sides together. So 5 and 4 are the two smaller sides of this, 7 being the greatest side. So as long as 5 plus 4 is greater than 7, then this can make a triangle. And it is. 5 plus 4 is 9, and that's greater than 7. So yes, these can be the side lengths of a triangle. On the second one, the two smaller sides are 3 and 7. So for this to be a triangle, 3 plus 7 would have to be greater than 11. Well, 3 plus 7 is 10, which is clearly not greater than 11. So no, this cannot be the sides of a triangle. So what would happen is you would have this side length of 11, you would have this little side length of 3, and this little other side length of 7, and they could never join together because they're not long enough. So we need the two smaller sides to add up to be greater than the third. Now, notice it doesn't say greater or equal to. So if I threw in a third example here and I said these are my three sides, now could that work? Well, is 3 plus 7 greater than 10? No, it's equal to 10. So what would happen there is, again, those sides would just fall flat. They would never be able to make a triangle. So you would have a side of 10, a side of 3, a side of 7, and they would just lay flat. They would never be able to join together to make a triangle. So it has to be greater than, not equal to the longest side. Okay, so let's look at number 6 on your notes. It tells us the measure of the angles, not sides. So we're not using what we just did. We're using angles of a triangle are 2x, 3x, and 4x. We want to find the value of x and then the measure of each of those three angles. Well, what do we know about angles? Well, let's look back at number 1. We know their sum has to be 180 degrees. What does sum mean? That means they have to add to equal 180. So on number 6, we're going to take the 2x and add the 3x and add the 4x and say that those together, those three angles, have to add up to be 180 degrees. So then it's just algebra. These are all like terms. So we have a total of 9x equal to 180. We can solve that by dividing by 9, and so we get x to be 20. Now it says, what is the value of x? We did that. It's 20. But it also says to find the measures of each of the three angles. So now we have to put that 20 in for the x in each one of those expressions. So the smallest angle is 2 times x. 2 times 20 is 40 degrees. Don't forget the degree symbol because it's an angle measure. 3 times x would be 3 times 20, which is 60 degrees. And 4 times x would be 4 times 20, which is 80 degrees. We can double check just to make sure that those do indeed add to be 180. 40 plus 60 is 100, plus 80 makes 180 degrees. All right, let's look at our final example, number 7, finding the values of a and b. So the easiest thing to start off with here, we know these three have to add to be 180, but we have 2 unknowns. So that's going to be impossible to know what each one of those has to be individually. What we need to do is start right here. This b and this 65 degree angle, they together make a straight angle. So together they have to add up to be 180. So I'm going to start with b plus 65 has to equal 180. So then I can just simply subtract 65 from both sides to find that b is 115 degrees. So now that I know this one is 115 degrees, I can find a. because using number 1 on our notes, we know the sum of these 3 angles has to be 180 degrees. So the A plus the 28 degree angle that was given plus B, which we found to be 115, have to add up to be 180 degrees. So we can add the 28 and the 115 together to get a total of 1353, right? Sorry, 43. Mrs. Hale's math bad. Okay, so 28 and 115 make, was I right the first time? Good night, guys. Maybe I should just write this down. 13, 3, 4. No, I'm right. 143. All right, so now we have A plus 143 is 180. We can subtract the 143 from both sides to get A to be 37 degrees. So A is 37. You can double check adding 28, 115, and 37 together to make sure that they do add up to be 180. I do want to show you something that we'll get to later in the year. Notice this outside angle, we call this an exterior angle. Notice that it equals the sum of these 2 angles together. 28 plus 37 is 65. So that is a relationship that we will look at later in the year as well. Okay, so I think that is all of our lesson. Why can the sum of the 2 sides of an angle triangle not equal the length of the third side? Remember, that's because of this drawing right here. They just would never meet up to make a triangle. This would fall flat, and so you wouldn't get a triangle. All right, have a good day.